Um, Sometimes you get an equation and you want to solve for x, but you have difficulty with x being in weird places. Like, for example, here we have x in the denominator. Remember, these are called rational functions because they have ratios with variables in them. Okay? So how do we solve this since we have x's in the denominator? It's very inconvenient. Not only is it inconvenient, but it's a little bit dangerous because if you remember, if you have variables in the denominator like we've been working with recently, there's a possibility that this denominator might become zero. And if it does, then the whole equation becomes infinity and it's very ugly and you have an asymptote. So let's figure out first what values of x would be dangerous in this case. Well, I can see that if I have x equals -2, then that would make these fractions into infinity. So let's say that x is not equal to -2. Okay, and then let's try to find the solution. Okay. So we have x in the denominator. We do not want x in the denominator. And remember, back a few years ago, you learned a method of bringing denominators up into the numerator by doing what we call cross multiplication. If we do cross multiplication, then these two can be multiplied together and put on the left side. These two can be multiplied together and put on the right side. So let's do that, and then we will have an expression which does not have variables in the denominator. There we go. When we do this, we can also see that we have the same factor on both sides. We have x plus 2 on both sides. So we can divide both sides by x plus 2, and we can get rid of it. Now we have x squared equals 4. X squared equals 4, we're going to take the square root of each side. Square root of x squared is x. The square root of 4, remember, it can be plus 2 or it can be minus 2. So there's two possible solutions to x, plus 2 or minus 2. Hey, wait a second. Didn't we say at the beginning that x can't be -2? This is also what is called an extraneous solution. We worked with extraneous solutions before when we worked with absolute value. And in this case, we need to check to see if both of these really are solutions, because especially when you have variables in the denominator, there's a possibility that some of the variables are going to cause the equation to become infinity, so you don't want those solutions. So in this case, the -2 solution, we already said at the very beginning that x is not -2, so we eliminate that solution, and the only solution left is +2. Okay? If you forget to define all the illegal solutions at the beginning, one thing you can do is you can go back to the original expression and put in each of your found solutions. So we could put +2 in here. We'll get 2 squared over 4 equals 4 over 4. And you can see that we basically have 4 over 4 equals 4 over 4, so it's fine. If we put -2 in here, we would get -2 squared on top, and we'd have -2 plus 2 in the bottom, and this would become 0, and we can see why -2 makes everything infinity. Okay? So there's two options. One is, at the very beginning of your process, you could define what are the illegal values and check back with that when you find your solutions. And the other is that you find your solutions first, then go back and put your solutions into the original expression to see if they still work. Okay? All right, let's move on to one more problem. This is a little bit more complicated. It has variables on the top, variables on the bottom. We want to get rid of the variables on the bottom. Oh, by the way, what are the legal variables, the illegal values here? Well, we don't want f to be -9, and we don't want f to be -7, because if they were, then it would the fractions would become infinity. So let's see what solution we're going to get for f, and after we do, we'll check to see if one of the solutions is -9 or -7 and eliminate that. So we are going to do cross multiplication. And when we do cross multiplication, we are going to do FOIL. The reason why we're going to do FOIL is we need to combine like terms, try to put everything on the left side and put 0 on the right side, and then we we use factoring to see if we can figure out what f should be. We're going to get a quadratic maybe, okay? So let's do FOIL, and then we'll get f squared minus 9f plus 7f minus 63 equals f squared minus 5f plus 9f minus 45. And I see immediately that we have f squared on both sides. We can subtract f squared from both sides and we'll simplify it a little bit. Then we have negative 9f plus 7f. That will give me negative 2f minus 63. And on the right side, negative 5f plus 9f. That would be 4f minus 45. Now I'm going to add 63 to both sides and subtract 4f from both sides and combine my like terms. I'm going to get negative 6f equals 18. So in this case, I'm going to divide both sides by negative 6. So f is equal to negative 3. So that's my solution. Let's check to see if negative 3 is a valid value for f. And it is, because the two illegal values were negative 9 and negative 7 only. If we do plug negative 3 back in here, we'll see that we get negative 12 divided by 6. And on the right side, we'll get negative 8 divided by 4. And you can see that that is negative 2 equals negative 2, which is fine, okay? So we can either take the negative 3, check back to see what values we prohibited in the beginning, but if we forgot to do that, you could take your negative 3 and then substitute it in and see if you get a valid statement, okay? So the steps are cross multiply, so that you can get everything out of the denominator. Expand if you have to, combine like terms, and then solve algebraically and get an answer. And then check to see if that answer is going to make everything infinity. If it doesn't, then you're fine. And remember, those solutions which do cause everything to become infinity are called extraneous solutions.